Good afternoon and welcome everybody. It's great to see so many people online for today's workshop. First things first, let me introduce today's workshop team. Each member of the team is here to make sure that you have a great experience and you can get the most out of the hands-on workshop. Our primary host for today is Vihag Gupta. He is a senior solutions architect at Qubole, and he'll be guiding us through the entirety of the workshop. So that's from setup to platform level intros to the live execution of workshop modules, followed by the hands-on phase, and then all the way to the end where we have a quiz lined up for you. Basically, he's our front man for today. VHAG will be supported by a workshop coordinator team made up of some of our finest solution architects at Qubole. They're here to help you navigate the hands-on workshop. So while you work alongside the workshop user guide that has been emailed to each of you, they're here to help make sure that you make your way through each module accordingly. We have Nishant Patel, Mayoresh Pandey, and Gerald Law from the Solution Architect team available. I'll cover off how to utilize them in the next slide. Finally, we have Ashish Kumar, Lead Solution Architect at Qubole, who will be giving us a platform overview to kick things off. So now for some housekeeping. As we have such a large audience online today, we're keeping everyone on mute and cameras off to ensure that the workshop keeps on track with timings. Although this is a virtual event, we really want this to be as engaging as possible. So you can use the different features in Zoom to interact with the workshop coordinators. Zoom chat should be used to pose any questions relating to the hands-on workshop modules. Use this if you need any help, and you can expect a response from the coordinators via Zoom chat. Also use Zoom Q&A, all available at the bottom of the Zoom control. If you wish to ask Ashish or Vihag to answer any questions around Qubole, Hive ACID, or streaming, or anything in between, really, we will answer as many questions as possible at the end of today's session. Finally, we'll have a quiz at the end to see what you've learned from today. So I've got one more slide to go, and then I'll pass it off to Ashish Kumar, who will close out the first agenda item with a platform overview. Vihag will then walk you through the workshop, and then it's time to get hands-on. We'll then spend around 30 minutes or so to run through the quiz and Q&A, and we're going to have a couple of prizes on offer for the quiz. So finally, and probably more importantly, if you wish to get hands-on today, then it's really important that you follow the invitation that you've received in your email. It will have come from notification@qubole.com, and you can also search for Vihag at Qubole to locate that email. So without further ado, I'll hand off to Ashish, who will give you a platform overview.
Thanks, Matty. Let me share my screen. So I hope my screen is visible. All right. So first of all, I would like to thank everybody for taking time from your busy schedule and attending this session. I'm very excited to see the number of participants here. Just to quickly introduce myself Ashish Kumar, and I work as a lead solution architect for Qubole. And it's been around 3 years for me working with Qubole. I work with some of the major customers in APAC region. Today, I'm gonna walk you through with the Qubole product info introduction, and then I'll be talking about streaming and Hive ACID capabilities in a bit more detail. After that, Vihag, who is also a solution architect in Qubole, will be demonstrating the workshop and take it ahead. All right. So I'm not sure how many of you have already heard about Qubole. So let me start with the brief introduction of the Qubole platform. So Qubole is a simple, open, and secure data lake platform for machine learning, streaming, and ad-hoc analytics. The platform provides end-to-end services that reduce the time, effort, and cost required to run data pipelines, streaming analytics, and machine learning workloads on any cloud. Yes, we do support Azure, AWS, Google Cloud, along with the Kubernetes support. For Ad-Hoc and streaming analytics, the platform's workbench lets you author, save, collaborate, and share reports and queries. You can develop and deliver Ad-Hoc SQL analytics through optimized SQL options. So we do support Presto, Hive, Spark SQL options for writing the SQL queries. And third-party tools such as Tableau, Looker, ClickView, etc., can be integrated easily with the platform. If you have, let's say, some BI tool which is compatible with JDBC, ODBC connectivity, so we do have drivers as well. So you can also build a streaming data pipeline combined with multiple streaming and batch datasets to get real-time insights. For machine learning, the platform provides capabilities to build, visualize, and collaborate on ML models. Platforms ML specific capabilities such as offline reading, multi-language interpreters, and version control deliver faster results. You can leverage Jupyter and or Zeppelin kind of notebook to do the development and use the integrated package manager to update the libraries in R, Python, or Java at scale. So we support Conda, CRAN, PyPy repositories for package management, which can be used by data scientists to get the package installed from UI itself without any dependency on the DevOps or data engineer. Recently, we started supporting RStudio, which you like if you are a R language pro. Additionally, MLflow as a service is there for tracking your model performance. With respect to data engineering, which has been the focus of Qubole from long time, the platform automates pipeline creation, which could be real-time, near real-time, or batch processing. Platform provides multiple options for monitoring like Prometheus, Datadog, Ganglia, along with plenty of pre-built alerting to take care of infrastructure health. You can easily create, schedule, manage workloads for continuous data engineering. You can use the processing engine and language of your own choice. We have support for Spark, Hive, Presto, Python, R, Scala, etc. We do support Airflow as a service as well, for complex workflow management. So if you have, DAG kind of, requirement where there are multiple jobs and those are dependent on each other, so you can use Airflow for dependency management of the workflow. Additionally, we have Java and Python SDKs along with the REST API support. So as a data engineer, you don't want to write your code right from the browser or notebooks, right? So in that case, these SDKs and REST APIs are going to be really helpful. If you want to integrate with version control systems like GitHub, Bitbucket, GitLab, that is also possible. So we have integration supported. For the use cases, I'm describing, the platform reduces the complexity at data management level and eliminates infrastructure complexity. So data management services improve performance and response times for queries, leading to faster data discovery. With built-in ACID support for transactions, you can avoid lost updates, dirty reads, and enforce app-centric integrity. The platform runtimes automates the cloud infrastructure, provisioning, deployment, and further optimizes it with workload-aware auto-scaling, cluster lifecycle management, intelligent spot management, heterogeneous cluster management to give you the best TCO industry-wide. So we have patented, workload-aware auto-scaling algorithm supported in the platform. Along with that, we have spent a lot of energy and cost on making spot of management seamless for the end user. So further, platform has built-in security and governance control, which are enterprise grade, like providing ACID compliance for granular read-write with respect to GDPR and CCPA compliances, RBAC and IAM integration with respect to cloud providers. So if you are, let's say, if you're using AWS and you are having IAM role-based setup, so that can be easily integrated with the platform. For SQL layer, RBAC, we have region integration supported, and we have SQL standard auth support as well. So why Qubole matters, right? As I said before, Qubole delivers a simple, open, and secure platform that will address the diversity of use cases. Multiple data format, whether you are using, Parquet, ORC, Avro, kind of, cutting edge formats, or like legacy format like JSON or XML, etc. And clouds that your users and enterprise would want, whether you are using Azure today, tomorrow you want to use AWS, or maybe after that you want to choose Google Cloud, you can do anything. It provides a near zero administration experience for your data admin team by automating the daily tasks needed to provide users with access of your data. It is based on open standard and is agnostic with respect to cloud providers, as I mentioned earlier. So you're not logged into a single provider. So when we say open, it means we are basically totally on top of open source technologies. So there is no vendor locking. If you want to do the same code whatever you have developed on Qubole platform, and you want to choose something else tomorrow, you are free to do that. So it provides the right level of security and governance, not only for the data access, but also for the managing the pipelines that users are building. It delivers built-in financial governance to help you optimize and reduce your cloud spend so that you can reinvest those resources in creating and running additional workload to get even more value from your data. Our cost governance can provide you the data at different levels of granularity. So in this COVID-19 situation, and this is TCO is going to be the paramount requirement for all the organizations, right? So in that case, with the help of cost governance utility in Qubole, you can get the cost at account, cluster, user level, and even job level. So that way you can easily figure out, okay, these are the 100 jobs running on platform, and out of 100, these 5 are basically taking the most of the resources. So can we optimize those more, or do they really need, right, at this point of time? So those kind of optimization can be derived with the help of cost governance utility. And it delivers all of this while giving your users self-service access to the trusted sources of your data directly in your data lake platform, giving them the fastest possible access to your data and the insights it contains. So whatever functionality I'm talking about, everything is going to be self-serve in the platform. So in a nutshell, if you have to basically define the value pillar of Qubole, so there are 4 value pillars as you can see on the screen. Right, the first one is simple, open, and secure platform. Just to reiterate, Qubole will address the diversity of the use cases, data formats, clouds, processing engines, and still be very simple to use and has enterprise-level security solutions. Then faster adoption of your data lake. So this is very important, right? If you're trying some big data, for the first time, or maybe you are very new to this whole ecosystem, it is always going to be a time-taking process, right, to have something in production. So because of the self-service and easy to use nature of the platform, it helps to expedite the data lake adoption org-wise. So we do have an enterprise level support team, which is available 24/7 for the customer. We also provide SMEs hours regularly to help the customer. Let's say if you're having some architecture level, discussion requirement or performance tuning, configuration management. So we have, some experts, right, who can help you to expedite, the overall development process. So the third one is near zero administration. So Qubole will take away the majority of the mundane daily task of managing, governing, and operating data lake, and also provide financial discipline, enterprise grade security, and data governance for your data lake. Just to give you a data point, in my last company, I was using Qubole, and we had around 500 plus analysts. And to maintain the infra for those many users, we had only one part-time data admin on Qubole platform. So that we were able to save a lot of admin cost as well. So the fourth one is, the reduced data lake cost. So Qubole puts saving cost first for the customer, which can be reinvested in use cases running more workloads, derive more results. So, this is going to be really crucial, because if you are having 100 workloads running at the moment, in this situation, you don't want to, continue spending more money on, having basically running something which is not very necessary, right? So because of the workload aware auto scaling, spot management kind of optimization, the whole platform is going to be very cost effective. In this crucial COVID-19 time, Qubole can be really, available, with respect to TCO. All right, so this is, pretty much about the introduction of the Qubole. So let's move forward. So coming to the first topic of the workshop, streaming. So I will start, talking about streaming with my experience. So around 6 years ago, when I was working for a leading cab aggregator company in India, I got a chance to lead the data platform team there. When we started, there was around 100 to 200 MBs data coming every day. And we had a couple of Apache Storm topologies to process that data for analytics. Within a few months, that became tens of GBs, and Storm topologies didn't scale for that growth. Hence, we had to choose, batch processing mode of, doing the same with Apache Hive and Hadoop tech stack. The solution was scaling fine. Of course, right, Apache, Hadoop and Hive, were very proven till that point of time. So it was able to handle around 2 to 3 terabyte data per day. So far, so good. We were, having all those, Nirvana state till that time. Then the time came when we started, getting use cases around more real-time data. Like the analytics team was expecting data refresh every 5 minutes for some of the very crucial data. Fraud detection team wanted to catch the fraud real time. For example, one driver should not do more than 3 bookings in the last 15 minutes. Then security team wanted to detect the suspicious anomaly in real time. For example, more than 1,000 requests or 2,000 requests come from the same IP address within 1 minute. If this is the case, it means something is fishy. And plenty of more, similar use cases were there. Hence, we had to build a streaming platform to handle all these use cases and handle numerous challenges. So I would like to highlight some of the challenges here, like scalability, reliability, monitoring, alerting, efficiency, fault tolerance, RBAC, and of course, right, efficient development lifecycle. It took us around 10 to 12 months to build an MVP solution to handle few of those challenges, not all. So you understand, right? The streaming solution running in production is not something which is very trivial even now. So what is the streaming analytics? So the streaming analytics or real-time analytics for data analytics that presents real-time data and allow for performing simple calculation with it. Working with real-time data involves slightly different mechanism as compared to working with historical data. Because if you are running something as part of your streaming pipeline, if something goes wrong, and let's say something goes down, you won't get enough breathing space to recover, right? So in that case, in case of batch processing, you get enough time to fix the issue and redeploy the solution. But in real time streaming solutions, you won't get that kind of liberty. So how basically Qubole can help with respect to these challenges? Here we go. So introducing Qubole streaming pipeline. So this is a UI-based wrapper on top of a Spark structure streaming, which can source data from Kafka, Kinesis, and S3 kind of sources, and provide things like object storage, S3, Azure Blob Storage, Google Cloud Storage, and data warehouses like Hive, Redshift, Snowflake, BigQuery, and then NoSQL DB options are also available as things like Elasticsearch and MongoDB. So without writing a single line of code, you can deploy your pipelines for basic use cases where you can directly dump your data to the available thing. So you can, let's say, basically I just want to deploy some very basic pipeline, which is taking data from one of the topic of Kafka, and it is just doing some aggregation on some column and dumping data into Redshift. For this particular pipeline, you don't need to write a single line of code. You just have to add some configuration values from the UI, and pipeline will be up and running in a moment. You'll be seeing, right, that experience in the workshop today. Then if let's say if you don't want to do drag and drop functionality and you want to actually write some code for complex business logic, so you can come up with your own code or jar for adding your own business logic. For example, let's say if you want to notify on some specific anomaly, right, coming in from some signal, right, and you want to have some business logic for defining the rules for getting the notification. So those kind of things you can do by writing custom code as well. So once you have the data available in your data lake, you can use different processing engine, right, for processing that data, which is coming, as part of our streaming pipeline. So once the data is available, let's say in real time in your data lake, and you are already having some historical data, you can just, club both the data set, right, for additional, insights. We have Presto, Hive, Spark SQL, engines, right, for adding the code. And if you want to do some, coding in Scala or, Python with respect to Spark, you can do that as well. So the next one is why Qubole pipeline? So you can easily ask, right? Spark structure streaming is something which is already there in open source. So then why, how is it different, and why do you need Qubole for that? So Qubole provides a UI-based solution which can be which can be used for pipeline management. So you can start, stop, pause at any point of time your streaming pipeline, and you can also do editing of your code from UI itself, right? And if you're doing editing, you would like to redeploy the topology, right, of pipeline. So in that case, before redeployment, and let's say if you just want to do test run, you can do that as well without hampering the actual sync and checkpointing locations. So workload aware autoscaling is supported for streaming clusters as well. In this streaming world, workload traffic varies. So for example, at peak hours, it could be heavy traffic, which may need more compute resources. And at lean hours, you may not need that much capacity. So autoscaling clusters are going to be really crucial for your streaming cluster, streaming pipeline as well. Then we have inbuilt checkpointing. which could be helpful if your pipeline stops and restart because of some reason. For example, if you are changing some business logic and redeploying the pipeline, then Qubole will make sure that it is starting from the same position where it was left last time. Then we have, alerts on failure, to channel of your choice. So you can, let's say something is going wrong in your pipeline, so you'll get notified on, a Slack channel or, email notification, PagerDuty, all those options are available. With respect to monitoring, we have Prometheus monitoring, which can be really helpful to monitor all the streaming pipeline which are running into the system. And then we have integrated Spark Lens for profiling, which is basically, an open source contribution from Qubole side, and that can be used for profiling tool. In this case, we have integrated that profiling tool with, Qubole, and this is, this will help you, right, to figure out if your cluster capacity is under provisioned or over provisioned, and this will help you, right, to lowering the cost and or controlling the cost. Then apart from that, we have error sinks, which helps, right, if some of the records are not following the defined schema. So let's say if you're getting, records very fast in your streaming pipeline and some of the records are not valid, so in that case, we can easily, sync those records to some predefined location. And you can just look at those record, right, maybe at some point of time. And for transition system, we do support ACID table as sync as well. So we'll be having that as part of our demo. And as I mentioned earlier, right, so we have enterprise grade support, which is going to be there for all the components. So moving forward, so the next component for today's workshop is Hive ACID. And ACID is, something which is very legacy, right? If you are coming from RDBMS background, then you would be knowing the ACID concept very well. Just as a refresher, right? Atomicity means a transaction should either completely successful or just fail. There should not be any partial success, right? Consistency ensures that any transaction will bring the database from one valid state to another state. Isolation states that every transaction should be independent of each other, right? That is, one transaction should not affect another. And durability states that if a transaction is completed, it should be preserved in the database, even if the machine state is lost or some failure, happens. These principles are going to be very much applicable in data lake as well, if you have concurrent read-write use cases. So if you don't have concurrent read-write, scenario, in that case, Hive ACID is not going to be, adding a lot of value. So if you have concurrent read-write, scenarios, so in that case, this functionality can, help you a lot. So let me tell you one example. So there are different, ingestion tools, right? Like Kafka, Scoop, Spark, which can add data into data lake at different speed. While these tools can write data at rates of, hundreds or, more rows per second, Hive can only, add partition every 15 minutes to an hour. Adding partition more often leads quickly to an overwhelming number of partition in the table. So if let's say if you're having minute level partition, let's say 15 seconds level partition, so there'll be too many folders, too many files created. These tools can stream data into existing partition. There is no problem, but this would cause reader to get dirty reads and, even so many small files. And right, these are like, the very classic problem of big data ecosystem. If you're having too many small files, the read queries are, going to struggle a lot with respect to performance. With this new functionality, this use case will be supported while allowing readers to get a consistent view of the data in avoiding too many small files problem. So you can see there are multiple use cases I have defined over here. So the first one is streaming ingestion of data. So as I mentioned earlier, if you are getting data via some streaming pipeline and want to update your table at regular interval, then Hive ACID could be useful. And slow changing dimension, this is a very typical requirement for all the organization. In a typical star schema data warehouse, dimension tables change slowly over time. For example, in a gaming company, if one user was registered last year and now he just updated some personal information, and the changes need to be reflected into the data lake. So in that case, you have to update user related information which belongs to the last year data. So in that case, in this case also, ACID functionality can be useful. Then sometimes it happens, right, you are having some incorrect record in some of the partition and you want to just correct those records. So in that case, update command from ACID can be useful for updating few records instead of just updating whole partition. Then bulk update, again, this is very classical problem when you are having CDC architecture, then merge commands are going to be really helpful. So any transactional data which is coming as part of your CDC pipeline can be merged to the historical data. So we are having some exercise with respect to this in our workshop today. And with respect to GDPR and CCPA, where you want a right to be forgotten, this insert and update, delete kind of functionalities are going to be really helpful. For example, if in billions of records, if you have to delete few users PII, then you can easily delete with ACID functionality. So I'm not going to talk about how ACID works in detail, but let me just give you a basic idea about it. So Hive ACID works by maintaining subdirectories to store different versions and update, delete changes for a table. The Hive meta store is used to track different versions. So let's say I'm running some update command, then delete command, and then let's say some insert command. For all those different operations, some delta directories will be created at your storage level, right? And which one is the latest version? That information will be kept inside Hive meta store. And to get rid of those many subdirectories over the period, we have manual and automatic compaction processes, and that can be used for merging those delta files, right, to make it more efficient with respect to performance. So again, right, so we have done a lot of work in Hive ACID since the last year. I should say we have spent a lot of time, and this is I think one of the very crucial initiative in Qubole at the moment. And if I have to talk about the kind of enhancement we have done in Hive ACID, so we have multi-engine compatibility. So we can use Spark and Hive engines for writing the data into transactional table. And for reading, we have Presto, Spark, and Hive, all three engines supported. And we do have Parquet support. If you see, the Hive ACID from open source, that only supports ORC, but we have additional support of Parquet. And merge command, which as I mentioned earlier, that can be used for basically, merging your delta data to the snapshot or history. For that merge command, currently open source is just having Hive support for merging. We have merge command option in Spark as well. And then, the next couple of features are a bit more technical. Let me try to explain that. Direct writes for inserts and compaction. Here we don't need to write to the intermediate location, and hence we get better performance. So this is something which is there in Qubole from long time, where we don't write to the temporary location as part of our Hive query or Spark query. So in that case, it is directly going to be writing to the final destination. And the same functionality here is we have integrated with Hive ACID as well. In this case, for inserts and compaction, we actually directly write to the final destination. Hence, we'll get better performance. And blob store commit maker, this is just to avoid reading partially written data. So yeah, so this is about the Hive ACID, and then this is pretty much from the presentation side. And now I will invite Vihag to demonstrate the workshop and take it ahead. Thank you, everybody.
All right. Yeah, thank you, Ashish. That was really insightful. To all the attendees, well, welcome again. I am Vihag. I am a senior solutions architect based out of Singapore. I've been working with Qubole for close to 2 years now, and I work alongside with Ashish, who we fondly call AK, in some of the most major accounts that we handle around here. So at this point, I'm pretty sure everyone is kind of done with the theory. It's really time to get hands-on with the workshop. So let me just quickly get started with that, right? So coming to the workshop, right? As the title says, we are here to sort of look at how to kind of operationalize streaming analytics and how do we sort of place the capabilities of Hive ACID in the picture, and overall, how does a platform really support the whole ecosystem as such, right? So as part of this workshop, what we are going to be doing is we'll basically work through various stages of building a data lake via a streaming pipeline, right? There are many things you can do in a data lake. We are focusing on streaming pipelines for Ad-Hoc analytics today. So in 4 different sections, we will be performing some data ingestion and exploration, both from blob storage like S3, as well as a real-time messaging system like Apache Kafka. We will see, as Ashish promised, how to sort of quickly codelessly deploy a real-time pipeline, and further see how Hive ACID sort of allows you to perform transactions and inserts, updates, and deletes on the data lake, on this data that you have ingested from, say, Kafka. And finally, we will see how you can also go ahead and perform some data analytics, some visualizations, and create dashboards out of it. Of course, everything is happening on the Qubole platform. Right. So moving on. So as a quick background, right, like every workshop needs to have a story. So what we are going to be doing is we are going to be looking at COVID data, because COVID is sort of the flavor of the season. That was a bit crass, but that is what it is, right? What we have done is we have collected some data from Johns Hopkins University, and they have kindly sort of allowed people to have the free data. And what we have collected is data from the start of this pandemic all the way up to the 1st of June. And we have reserved all the data beyond 1st of June as sort of, a streaming simulation. So we'll be setting up a Kafka system for you from which you will be able to read all the data beyond June 1st from the Kafka system in sort of a simulated real-time fashion or a streaming fashion, right? In terms of concrete activities, here are what we're going to do. The first thing we'll be doing is creating your own data lake. Every person here gets their own piece of the data lake. We'll ingest the historical data that is all the way up to June 1st into the data lake and make it available as Hive tables. And once we have that, basically you can go ahead and query the data via a big data engine of your choice. Next, we will deploy a streaming pipeline using Qubole's pipeline offering, and which will be entirely codeless. And what we'll be doing is populating some Hive tables via the pipeline. Next, we will be looking at Hive ACID transactions. We will combine both. We'll perform some ad hoc inserts, updates, and deletes, as well as we also have an advanced use case of merging, say, the latest COVID data with, say, the snapshot data. A snapshot data here represents the latest numbers throughout the world, right? And the numbers could here be basically the confirmed cases, the recovered cases, or the fatalities. And finally, we'll do some interesting analytics. We'll be doing some analytics using Presto. We'll also be doing some visualizations using our notebooks. And we have like a fun map-based visualization to sort of work through it. So moving on. This is sort of the overall workshop architecture that we will be going through. On the left-hand side, this will be our real-time source, which will be a Kafka system that has already been set for you. All you have to do is subscribe to it. Qubole's pipeline service, which each one of you will be setting up, runs on Apache Spark as a operational structured streaming process. And from this pipeline service, we will be basically staging this received data into some transactional tables, which is Hive ACID tables, and finally creating some snapshot views of the overall data, and then move on to some basic analytics using Spark and Presto engines. In terms of the data flow itself, as you see, basically pipelines will be reading, from Apache Kafka as structured streams. Then we'll be doing some incremental stream loading via our pipelines into a Delta table, which hosts this received intermediate data. And once we have all this data based on some sort of a cadence, we will be merging them into the final snapshot table, which is a transactional ACID-based table. What this means is we'll be looking at all the new records that we have received here, and we will compute and merge only the latest numbers for all countries and states into the snapshot table, which will be opened up for our end users for analytics, right? And we'll also be doing one batch component, which will be at the very, very start of it. Right, so time to get hands-on, right? So first disclaimer, even though we are using real data, real COVID-19 data here, please don't proclaim what you see here as something new or insightful that you might have. This is purely for representation purposes. COVID is a very sensitive topic, and we don't want anything being taken out of context here. So that is one. And two, the way I'm going to present this is you might all have received this user guide in your emails, which says streaming analytics with Hive ACID. And as you will see, you have 4 different sections to it. All of these 4 sections, I will be sort of demoing to you as to how to go about executing it, some best practices, some tips and techniques. And once we are done with that, we will open up this session for basically hands-on time where you can follow the guide and perform these 4 modules by yourself. Don't worry if you do not have full time to complete it. Again, like the scope of this workshop is sort of ambitious. So we really appreciate your understanding in that. If required, we will keep the workshop open for a while so that you can go ahead and complete it. Right, that's it. Let's move on. So if you follow this particular workshop guide, there is basically an introduction that you can talk about. And what you will have is you can move on to the section number 1, which basically describes the data that we are getting and basically the architecture that we are going to run. And finally, it starts off with the actual execution. So here you will see you have to open your copy of a notebook. So all of you might have received an invitation already, and you must have already followed up to sort of get your own Qubole account. If not, please drop in your name on the chat so that the other workshop coordinators can set you up while I'm doing the demo. Right. For all those who already have this account set up previously done, you can just follow what I'm saying here. Right. So when you see this, open your copy. So basically you have to log on to your Qubole account. And on the left-hand top corner, you have this drop down where you can just go ahead and click on notebooks. Once you come onto notebooks, you will basically be greeted with your notebooks as such, and each one of you will have your own copy of the 4 notebooks that we'll be using today. That is data lake setup, streaming pipeline setup, transactions, and visualizations. So as part of the first exercise, we are going to be setting up our individual data lakes, individual tables and databases, right? So the first thing that you will be doing is executing this particular paragraph. Now it's okay if it takes a little while before it starts off, because right now it is starting off a Spark application. What this paragraph is basically doing is it is about to create a database for you, for your own personal use through this workshop. And it is instructing Spark that this particular user, in my case, Vihar, is supposed to be using this database called stream_analytics_Vihar. Right, so let us just wait for this to finish execution. Right, so it is done. So we can quickly check your data lake here. And basically, you can click on the tables here, which is the Qubole Hive Explorer, and go ahead and refresh this. And you will see that your own personal database has been created. Right now, we do not have any data or tables inside it. And that is what we will do next. So next, you will go ahead and create a table for the historical data. You just go ahead and click run. Just a quick note about the data, the tables, while you will be reading about them in your handbook. Historical data is basically all the data that has already been curated and collected for you. That is all the way up to June 1st. The delta data is what you will be receiving from your Kafka source. And snapshot data is basically the absolute current visuals of the COVID statistics that you might have, right? So now this has also executed, and it says that it took like around 4 seconds, blah, blah, blah. That is not entirely relevant. The idea is you can just see that your execution is finished. Moving on, now we have to load the pre-computed historical data into your data lake. That is up to June 1st. Go ahead and run this. So what it will do is it will go ahead and read some curated data from a particular location that we have opened up for you. And it will basically insert this data into our historical tables. So this is, if you think about it, a pretty general pattern, right? In terms of, a data lake. You have a baseline ingestion that you do, and day on day or hour on hour, or something like that, you have to keep on updating more and more information that you get. And that is what we are sort of simulating here. So right now, what we are doing is basically setting up your base tables. And then we'll move on to setting up our streaming pipelines. So now this is done. Then we can move ahead and create the skeleton for the delta table. It's the same as what we have for our historical data, only that we have different data types and more curated data types here. Once that is done, we also create the final snapshot data. The snapshot data will be the table that will be opened up to analysts for final querying of statistics. And what we're going to do is we are also going to initialize the snapshot table with the latest snapshot of the data. So what we are going to do is we are going to look at the historical data and figure out what is the latest COVID statistics, that is confirmed cases, fatalities, and recoveries for every state and country combination that we have, right? So we just go ahead and run this. Right, so if you get an error like this, stay calm, just run it again. Right, so this will take a bit. Let's just wait for it to finish. So for SQL enthusiasts, this might actually be a very interesting exercise in understanding how this windowing function is working here and what is the need for it in a real-time place. Because as you would imagine, in a real-time system, you might get duplicate records depending on, well, the guarantees of whatever the source is, or basically, depending on the source system, you might get like multiple records for the same combination, in this case, the state and the country, and they might all have like different observation dates or last updating dates. So in this case, we want to just pick up the latest data for a state and a country, in which case we can just use some sort of a windowing function, which says that, hey, I want the latest row, latest row as defined by state comma country. And basically in, we want to sort of, pick up, the latest row. So that is what we are doing here, right? So once that is done, it's finished. Now, if you can see, go ahead and click on the Hive Explorer again and just refresh once more. And obviously, quite a lot of people are already up and running with this. This is perfect. So you will see that all your tables and delta data and everything is set for you. Once you're done with this, you can go ahead and explore some data. So just go ahead and click on the data exploration and visualization. I have already run this once before as part of preparing for this. So what you can do is, once you have the data, you can click on the settings here and play with the visualization here. In this case, what I'm saying is, by country, I want like the total confirmed recoveries and deaths. And basically, because of that, we are getting this sort of a distribution. Again, like you can play with getting different, running a different query here itself, and using different visualization tools as you might find relevant, or as you might find interesting. So this will necessarily be the end of section 1, right? So while this is running, let me just quickly run through into section 2 as well, right? So section 2 is about setting up the streaming pipeline. Now we have already set up our basic data lake, and now we are ready to receive our streaming data. So that is what we are going to do next, right? So for that, again, like I'm just going to leave this as an open exercise for you folks. What you can do is go ahead and click on notebooks and click on pipelines to open up a new tab. Also, on the same notebook, why don't you go ahead and click on your streaming pipeline setup. Now, in this case, you are not really doing a lot of stuff as such on your notebooks. This is basically a convenience notebook for you, where you can just go ahead and run these particular paragraphs to sort of get the latest, or rather some information that you will be required for running your pipelines. So in this case, it is telling me that this is the Kafka broker that I'm supposed to use while setting up my streaming system. So we'll come back to this quickly. So what in the pipelines, basically just copy your database name here, like this, streaming analytics _ we have. Come here, and this is the page that will greet you. Just go ahead and say create new, and you can choose a build assisted pipeline, which is the codeless system. And you can use the same name as your database. I have used this quite a lot of times, so I am just gonna append it with demo. Right, so go ahead and proceed. The first thing it will ask is to set up your streaming source, right? So which is a Kafka system. So go back to that notebook that we just talked about. Once you have printed out your Kafka broker details, just go ahead and copy it, right? And come back to the pipelines and paste it. In terms of topics, just add a topic named COVID. Again, this is part of your handbook, so don't worry if you missed that. Change the input format to JSON. And next you want to provide a schema. So again, that is provided to you in your handbook as well as this notebook. Go ahead and copy the schema, take this and paste it here. And there you go. And in terms of offsets, change it to earliest so that you don't miss any of the data, because the Kafka systems are already running. We don't want you to miss any data. So we are going to use the earliest offsets. Once done, go ahead and select next. And in terms of sync, choose a Hive sync. Sync is basically where you want to append the data to. Choose the database that you have created for yourself. In this case, analytics_vhug. Choose the delta table because this is our staging table, not the historical, not the snapshot. Choose the delta table. Then go ahead and set the properties. Right. So in terms of clusters, basically just go ahead and look at your own notebook. You will have a cluster number here attached to your notebook. In my case, it is 48172. If you just click on notebooks and go ahead to the clusters page, right? So if you look at 48172, you will find a name attached to it. And this is the Spark cluster that you are supposed to use for this particular workshop. In my case, I am going to use Spark Streaming UG1. It is very important that you use this exact one because that is where your Kafka systems reside, right? So that is what I'm going to do. Right, where is pipelines? Right. So I say Spark Streaming UG1. Go ahead. And next you want to have a checkpoint location. Again, use this notebook to get your checkpoint location. Right. Again, I have used this checkpoint location quite a few times. So I am just going to append it with demo, but you can just go ahead with whatever is there and leave the output mode as append. Next, go ahead to assisted code. While you can do a lot of things here, in this particular workshop, for the case of simplicity, we are not going to do anything. It is just a simple read from Kafka, dump to Hive. And what you can do is, and this is one of the cool features that Ashish was talking about, you can basically have a test run. So just go ahead and click on a test run. And what it will do here is basically read some data from the Kafka source that you suggested or specified here. It will try to process some batches, see if things are going, print out some results. And once you're satisfied with your test run and with your pipeline, you can go ahead and actually deploy it. Pipelines will automatically take care of returning your checkpoints to where they should be, and so that you don't actually miss any data when you have actually executed in production, right? So let's wait for this to run, right? So if you want to look at the logs, you can go ahead and look at the logs as to what is going on. So again, logs can be pretty verbose. If you are interested in reading Spark logs, by all means, you can actually go ahead and do it. If you want to reduce the verbosity to just errors and warnings, you can do that as well. Let me keep it as verbose as possible. So while this is happening, let us wait for this to finish. There are quite a lot of things here. You can also have an Avro schema registry if your systems already have it. If your data platform already has a schema registry, you can definitely apply a schema registry, and instead of copy pasting the JSON schema that we just did, you can actually just use that and import that. You can also switch from drawing mode to coding mode, as Ashish said. Like, you might want to have some more control and hence be able to code as such. So you can do that as well. Let's wait for this.
So in between, could you help us, right, to showcase how to change that ACID dependency from the notebook? So I just shared a couple of steps in the Slack channel. Could you just show to all the users how to add ACID dependency jar in the notebook?
Right, perfect. Yeah, thank you so much. Right, so it is actually mentioned as part of your handbook. So let me just quickly point you to where it is. So if you look at this particular section, it says that we want to add these particular two properties here. So what you can do is go ahead and click on your notebook. Here, you can click on interpreters. Just go ahead and click interpreters. And each one of you will get a separate interpreter, which basically translates to a separate Spark application, which will be something like user underscore your username and whatever your company is, right? So basically just go ahead and edit this. And what you will see is this particular field. To add, say, the first property, which is the Spark SQL extensions, you can just go ahead and add it here and provide the same thing here. So just go ahead and that's it. You are done for at least the extension, the ACID extension. And as far as the dependencies go, you can just copy paste that S3 location that we have provided into this particular location and go ahead and save it. Once you do that, your Spark application will restart to accommodate this new setting and this new artifact. As AK might have already been telling you, this is part of Qubole's innovation in terms of making Spark work with the open source Hive, and we are actively making it more and more robust. Right. Let's see if. So this thing has completed. So it says that my command has succeeded. Let's see what's happened here. So if you look at the event stream here, right, like it is saying that, hey, I processed quite a lot of rows at first, and then more and more rows as they were being received in different batches, we processed them. You can also go ahead and click on results to see the various data streams that you were actually fed. Right. So once you are sort of satisfied with this, go ahead and just deploy it. This is a very interesting capability, but let's skip this for now and then go ahead, review and deploy. Right. So while this is deploying, it will say that, okay, the streaming query should start in a few seconds. If you wish to see the logs of the actual running command in production, basically, you can go ahead and click on instances and logs and click on the command ID. It will redirect you to the actual running command, and you can go ahead and look at the actual queries. Right, so it has started off, and basically this is again like pretty verbose logs because, well, logs are good, and then it will start off. So I'll just wait for it to perform a few reads and hence writes into our final into our delta table before moving on. At this point, please go ahead and start executing at least the first two sections. Once we have accumulated some data in my tables, I will showcase how to execute the remaining two sections. Let me also look at different Q&As. So I know there are a lot of trigger happy folks in the participants, and I know I'm seeing quite a lot of familiar faces around, but the idea here is, so as you can see on my screen, basically now we have started processing offsets and we have started reading from Kafka, and it is saying that, hey, I'm processing these many rows per second and things like that. Again, like, please understand, this is more of a toy setup here. Right, so once we have this, that is your pipeline is actually running. So it is all good. And what we can now do is we can go ahead and start looking at this data as well. So quickly, you can go ahead and go back to your notebook number 2 and basically run a very basic query to see the latest numbers from the stream data, because the streaming data is pushing in data for a country and a state for across different dates and different times. So we might want to look at the latest data, right? So this is just like a very simple example that you might want to run. Go ahead and run this. Again, like what I'm going to also say is while Spark SQL is very cool, you must and you should take this opportunity to sort of try out Presto in the side as well. So just go ahead and copy this, and you can move to our Workbench interface. You can just again click on Notebooks and click on Workbench. This will take you to a page that looks like this. You can go ahead and say, I want to create a new collection. Click on Presto and just put in your query here. One thing that you will need to do is, because Spark has been instructed to use your own personal database, so that's good. In this particular case, you might want to add your own personal database to use. Here, we are looking at the COVID Delta data table. So what I'm going to do is I'm going to add my own personal database here. Right, so I go ahead and say run. And basically, because Presto is supposed to be built for speed, built for analytics, this is a much better choice for running your, debugging SQL queries, or, just looking at whatever SQL data that you might have. It's just way much faster. And as you see, it has already sort of finished and it has given you some results, right? So perfect. So you can have it, take some time, look at this data, or you can also go back to your notebook where our Spark SQL query has also finished, and we have been given some data here as well. So you can, again, like change the settings to sort of, change your graph as you wish, as you please. You can change your graph modes as well. Again, go ahead, play with this, see what makes sense the best for you. So now we have completed 2 sections. For those of you who are following, if you're not following and waiting for it to finish, no worries at all. Basically, at this point, we have already set up our individual data lakes, and we have also set up our streaming pipeline, which is feeding data to our data lake. So next, what we are going to do is we are going to look at transactions on the data lake. Now, historically, data lakes are HDFS and HDFS-like systems, which are immutable, and hence the concept of transactions, as AK mentioned, is sort of alien, and it's not trivial, right? So based on that, however, now the community is sort of building a lot of innovations around that, and Hive ACID is one of those which allows you to do transactions. So go ahead and click on your home and click on your third notebook, which is transactions with Hive ACID. Right, and basically, first what we're going to do is run a few inserts and updates and deletes as such, and then we'll also look at an advanced use case. So I know a lot of you have jumped the gun, but it's all right. First of all, again, instruct Spark to use your personal database. Go ahead and run this. It should be pretty fast. Next, go ahead and run an insert command. As you see, we are inserting into our final table some values for Miyazaki district in Japan, and say, go ahead and run. Right, so inserting shouldn't take too long, but as far as checking how it goes, I will strongly recommend not running this query here in the notebook. And there are, again, like if you are interested, you can try to find that reason. But if not, we can talk about that separately. But what I want you to do is don't run this SQL here, come back to your workbench, run it as a Presto query. So what you can do here is go ahead and just replace this. Again, make sure that you change it to your personal database. So I'm going to change it to stream analytics _ bhag, right? And just go ahead and run. It shouldn't take too long, and let's just wait for some confirmation that yes, we have actually inserted the data. Right, so there you go, it's inserted. Now, again, we can actually go ahead and run an update command where we are changing the number of confirmed folks, right? So go ahead and click on this. And it is running. So the reason why I am discouraging you from running this Spark SQL here in the snapshot data is for a very simple reason. As part of this workshop, we have sort of, forcibly slowed down everything, and not everything is in the most optimal fashion that you would want. So right now, while we are inserting data into the backend, we are not necessarily performing Hive compaction routines, which sort of take away the small file problems, because each and every insert is written as a separate file, and Hive ACID necessarily requires it to be compacted. We are not doing that because of the volume of folks we are expecting on the call. Because at this point we are running close to 50 folks, we don't want any experience to be bad. So we have turned off compactions, etc. So this query might be a bit slow on Spark. However, the way Presto works, it will be very, very fast, as you saw here in the workbench. So again, it is entirely for your own user experience that I'm suggesting that go ahead and run this on a Presto cluster. So let's wait for this update to finish. So while this is happening, right, again, you can go ahead and once this update is finished, you can just go back to Workbench, again, check if the serial number 50,001, which is Japan Miyazaki, has actually been updated to 105 or not, right? So you can do that, then again, check with delete, etc. So that's part of your user guidebook. You can try that. I'm just going to introduce you to this optional advanced Hive merge workshop section. So the idea here is, if you remember our deck, right, what we are going to do is basically, now that we are populating our delta table from our Kafka, we want to sort of merge the latest records from the delta table, because this delta table will contain at this point data all the way from June 1 to say June 20 for all sorts of country and state combinations. However, our snapshot table requires to be only the latest data, right? So we are going to use Hive's merge statement to basically look at the latest data from the delta table or the latest statistics and merge them into the snapshot, including any updates or deletes to the data. So how is that happening? Basically, if you go back to your guidebook and go to your section 3, let me quickly scroll down. Right, so here it talks about this optional section, and basically we have provided you with the query, which says that I want to merge into my final snapshot table some values that I select from my delta table, right? So this is that you basically pick up all the data from your delta table, and basically you are picking up in such a way that you are just picking up the latest statistics for COVID for every state and country, and looking at any updates or deletes that might have occurred. And then you are just taking those and finally merging them into your final table that you want to present to your, folks, right? So to your analytical folks. So let me just quickly copy this, or actually, sorry for that. Let me just quickly pick it up from my own analysis page. So I've already run this once. I am going to run it again. So we actually have two IDs, just in case you're getting confused. This analyze is the older version of this Workbench UI. It's just a force of habit that I stick to analyze. Anyway, so you can just go ahead and click on a new collection, say that you want to run Hive, switch this to Hive 3, because this is a capability that is available only in Hive 3. Paste this. And again, as before, you would want to change your database here to your own personal database. Once you have this, just go ahead and run. Now, again, as we mentioned, we have sort of slowed down and clamped down on the amount of resources that everyone can use. So this is going to take a while, but that shouldn't sort of stop you from performing any other sections, right? So again, we'll prefer that you do it, say, at the end of the 4 sections. But if you want, you can go ahead, try to understand this query, ask us questions about this. And yeah. Okay, I have some issues here. Let me just go ahead and run it here itself. So I'm just going to say run. And it has started running. Right. So it's going to run again, but it doesn't necessarily stop me from proceeding with my workshop. Right. So let me see if things finished here. Yeah. So yeah, so pretty cool. All done here. Again, like if you see failures like this, just go ahead and run again. It shouldn't be a problem at all. Right. Again, apologies for the inconvenience if this is bugging you, but again, it's not a fatal error. It is just as part of our preparation, sort of missed a few things. So apologies for that. So once you're done with this, you have basically gotten an idea of transactions. So you saw inserts, updates, and deletes. You also saw an advanced case of merging, right? So once you have done the merge, you can actually go ahead and do some visualizations on top of that as well. But we'll sort of skip that, right? So skip in my own presentation. Once you have done that, you can go ahead and go to your final section, right? So again, as before, so one of the things I will do is, so what we're going to do is just scroll down a bit and look at this particular paragraph, say present the latest statistics to users. Just go ahead and run this once, right? What it is going to do is, it is going to set up a map for you to work with. Now, just working backwards, you can go ahead and say to Spark that, hey, I want to use my personal database. Then what I'm going to do is enrich my statistics with country coordinates. So because we right now have country and state, we're going to use latitude and longitudes and plug them into our map. So I'm just going to go ahead and run this. It's going to take a while. And once it is done, we will have this map in an interactive fashion. So while this is happening, you can also perform some Presto analytics. So if you scroll down in your user guide, you can actually go ahead and look at the section analytics with Presto. And what we are going to do here is this query, what it does is basically compare the current, so the latest data that you have in your snapshot based on however far you have processed. It will compare how it is doing in terms of recovery rates to the best recovery rate of that country, state combination. So it might be that your recovery rate in this week or today is actually far better than any previous best recovery rates. So it's just like some sort of good news to sort of end this sort of workshop. Again, like if you want to flip it, and you can go ahead and also check out the mortality rates. But since I am a glass half full sort of a person, I'm going to use this best recovery rate option, right? So let me go ahead and copy this. Just give me a second. This is my working Google Doc. So I'm just going to copy this. Again, like if you are an SQL enthusiast, you will actually have a lot of fun trying to understand this query. Again, it's heavily dependent on windowing functions, etc. But yeah. So come here and click on new collection. Just go ahead and say I want to run Presto. Again, as before, my personal DB should be applied here. So I'm going to say stream analytics _ vHub. Right, and here we are basically merging our snapshot data, which is the latest data, with our historical data, right? So, right, so, and this is where we are reading the snapshot data, right? So I just go ahead and say run. So again, this should not really hold you from creating your own insights out of the data that we have given to you. This is one of the things that I came up with because I just wanted something cheerful to end the workshop with. It's a nice, happy note that, hey, recovery rates are pretty good now and things like that. But again, like do as you wish. This data is for you to play. So, right, so Presto has finished the query and it is saying, okay, let's look at some of the data. again, like you can clean up a lot of this data, but the idea here is that you can look at, say, Sri Lanka, where the current week has a recovery rate of 0.49, whereas its best week was the 15th week of the year, and the recovery rate was 0.21. Right. So again, like this is sort of a fancy sort of a thing. If you are an SQL pro, you can actually create a week-on-week rolling average to get insights like this. But the idea is, so you get like the basic idea here that pretty much do as you please, do as you want. Right. So this is this. So this is Presto Analytics for you. Very quick, fast. As you can see, it is way more performant than Spark SQL because of the way it is architected, and it is meant for analytical use cases. Coming back to our visualization, this job has finished. And as you can see now, this dropdown has been populated with data. So I can just click on this dropdown. Say, because I am sitting here in Singapore, I'm going to check out Singapore first. So it is just saying, it will point me to where Singapore is on the map. Not entirely accurate, but pretty close by. And it is saying that, okay, we have these many cases, we have these many recoveries and these many deaths, which is actually pretty accurate based on the data that we have. For those of you who are sitting in India, let's quickly search for India as well. Right, so I mean, like in the recent days, it has not been as good. So again, like that is what you see. Again, like this is based on the data we have. Please, 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 you do not take this to be, an actual insight that should be applied in the real world. The pandemic is not something to be trifled with. And finally, let's also look at something in the Western Hemisphere, right? So basically, one of the countries that sort of went the opposite way of lockdowns was Denmark. They said that we trust in our citizens to do the right thing, maintain proper social distancing, and we won't lock down our economies. And they actually worked, right? So Denmark actually has very little confirmed cases, very, very little deaths, and they do not have to suffer the economic consequences of a lockdown. So this is that. And finally, our good friends in the US, where things have, well, for the lack of a better word, shambolic. As you can see, ouch, right? So that's that. So this is your workshop in a nutshell. It is pretty straightforward. There are a few rough edges, as I mentioned, like in this particular notebook, I will prefer that you first run this paragraph and then work back because of the way, I mean, like I have coded the Angular code here. If you look at it, it's actually not the most pretty code. If any one of you knows Angular, please go ahead and clean it up a bit. We'll be very, very grateful. But yeah, that's that. So cool. So at this point, we are almost, I just ran like 10 minutes over. So why don't you take the next 40 minutes to sort of run through 30 or 40 minutes to run through the various sections of the workshop that we have curated for you. Again, like advance apologies for any rough edges that you encounter. As you sort of proceed with the workshop, please feel free to ask any questions you want. Doesn't necessarily have to be about the workshop. If you are curious about our take on how we see streaming in the field or how other folks do it, again, like we are happy to have a chat on that as well. So yeah, I will come back in around 30 more minutes to see how you guys are doing.
All right, thanks, Hive. So just to update everybody, right? So if you have any query with respect to the workshop you are trying out, please raise your queries in QA section, because in the chat box so many things are coming and going very frequently. It's very difficult to monitor from there. And yeah, and please if you feel right those queries are very complex and you are not a skill pro guy, right? Just try your own version of SQL query and run against Presto for analytics, and you can just try out Spark SQL or any other thing, right? You don't need to stick with the analytics query what we just shown. You can just have your own version. I know flavor. Thank you.
Right, so just looking at the webinar chat, I'm pretty sure like most of things would have been resolved by now, but there are a couple of things that I would like to say. Because we are using Spark heavily in the notebooks, at any given point in time, one user can run only one Spark job. If a previous Spark job is still running and you try to run a new paragraph and say, click on the run or something like that, what will happen is it will go into a pending state. It will wait for your previous job to finish. That is sort of how Zeppelin works. Uh, we can change that, but we won't for the purpose of this workshop. And the idea here is that you do it one by one. So if it isn't pending for a while, just be patient. Things will start running. Again, it is also possible that our clusters are actually auto scaling as we speak. So there is a possibility that your jobs are in the pending state because the clusters might not have enough current capacity as such, and Qubole is working on auto scaling the clusters so that there is enough capacity for everyone. In fact, let me just quickly check that out. So I'll go to my clusters page. As you can see, all my streaming clusters are running at capacity at this point. So if I look at the user group 1 itself, right, so we have provided that our maximum capacity is 10 machines of R4 2X, which are fairly expensive machines. We are currently running at scale, and we are combining with spot and on-demand nodes. We can also look at, again, like this is for anyone who is interested. I'm just checking it out. The idea is to see the scaling. And as we can see, the scaling here started like we jumped up to 4 machines at some point and then jumped up to 5. And because everyone started running, we jumped up to 10 machines. Again, like this is because we are capped at 10 machines. So apologies for the inconvenience. But then as you can see, like as Ashish was mentioning that with Qubole's auto scaling, we automatically provision more and more machines to provision for more workloads as they come in. Hey everyone, just checking back in. For those of you who are actually executing this workshop right now, the Q&A has been pretty quiet for a while. Let us know if you are facing any difficulties. We have a big team on standby to help you out. All right, folks, we are nearing the end of our hands-on session. We are just around 2 minutes to the close of this hands-on session. Again, if you still haven't completed the workshop, no worries at all. We'll keep the clusters up and open and your accounts up and open for some more time post the workshop. You can go ahead and complete the workshop at your own time.
Okay, as V had mentioned, we're just coming to the close of the hands-on workshop. So let's close this section off with the workshop quiz. We've got a couple of Amazon vouchers on offer, and essentially it's a multiple choice questionnaire, and the winners will be announced after the workshop. And essentially all you have to do is get your fastest fingers first. We're going to give you 3 minutes to answer the quiz via the poll, which will launch any second now. And those with correct answers through will be in the hat to win the Amazon vouchers. So I'm going to launch the poll now. You will see that come up on screen. Please take your time and go through this before the clock runs to 0. So the poll is live. Please go in and answer away. Good luck. Just to help you guys navigate to the poll, it's available at the bottom of the Zoom controls, and it should also be on screen for you. We'll run it for another minute, and then I'll end the poll. 20 seconds to go, and the quiz will end.
Right. Cool. I think so. We are done with the quiz, right, Matt?
Yeah, all done there. I'll just be tallying up the results in the background.
All right. So while we're doing that, let me quickly sort of summarize the workshop. So if you can let me share my screen. Right. So just quickly summarizing the workshop, right? For those of you who managed to get across, congratulations. If not, please keep at it. The end is near. In terms of what we achieved, right? We went through 4 sections, and we basically started off with our own data lake setup and creating a baseline ingestion. We ingested some structured data from S3 as well as Kafka. We'll get to that later. Once we had ingested that structured data, we created Hive tables on top of it and enabled querying on top of it using any big data engine of your choice. Then we set up our streaming pipelines in a no-code fashion where we just pointed our pipeline to a Kafka source and a Hive table to write the data to. And Qubole pipelines took sort of care of operationalizing the whole streaming system. Right. And once that data was available, the delta data that, as we were calling it, it was available for query via the Spark Presto as well as Hive query engines. Then we moved on to performing some transactions on the data lake. We looked at merge statements as well as primitive insert updates and deletes. And finally, we did some visualization and analytics using Presto and Spark. Right, and we basically leveraged Qubole's shared meta store where we had defined all the tables and the multi-engine support for all of these engines as well as for the Hive ACID use case. So that's it, right? Matt, over to you if you have the poll results.
So actually, we have a couple of correct answers, but I can't get the individual details of who's won until the webinar finishes. So we will be in contact post webinar to those to the top 2 that were the quickest and provided correct answers. So keep an eye on your inbox for more information on whether you've won or not.
Awesome. All right, so we still have 10 minutes on the clock. We are open for any questions and any help that you might require for completing any of the remaining workshop that you would have. In terms of next steps, as Matt mentioned, you will be getting like the poll results, etc. We'll also be sending out like survey results and survey questions. We'll really appreciate your feedback. I know there were a few rough edges here and there, but given the tremendous scope of the workshop, I think it was a fair execution. But do let us know what you think about it, and we'll definitely take corrective steps for our next iteration.
So if anyone has a question at this time, feel free to raise a hand and we can take you off mute to ask Ashish or Vihag any questions that you've got. Alternatively, pop your question into chat or via the Q&A. This is your time before we close to get any questions answered. So whether that's relative to the use case that you've seen today, any of the technology, Qubole, anything in between. So yeah, encourage you to make yourself known.
Hey Umapati, this is Ashish. You're asking about how this is something similar to database notebook, right? So yeah, you're right. So this is a Zeppelin offering from Qubole side. Along with Zeppelin, we have Jupyter in our studio. So in a nutshell, yeah, the notebook experience is going to be quite similar. And then the next question is, does this run in on-prem? So as I mentioned earlier, right? So we do support only cloud at the moment. So could you elaborate what do you mean by on-premise? So do you have some data center and you are working on some data, big data setup on that, or do you mean anything else? So Matt, can we unmute Umapati?
Buffy, you're unmuted, so you can talk.
Hi, can you hear me now?
Yep.
Yes,
Hello.
I can hear you.
Yeah. Just want to know about this can be deployed on the on-prem solution. I mean,
So currently, we are just supporting cloud. So whether you're using Azure Cloud, AWS, or Google, and Kubernetes support is something which is in our roadmap. It will take, I think, 3 to 6 months, right, to support on-premise.
Okay. Do you have any benchmarking about, suppose for example, so if I am posing 1 million or more than a million events per second, does this quite capable?
Right. So in that case, we have some benchmark. Maybe if we can reconnect offline, and we can share some benchmark from our side.
Yeah, we would like to know about this. Yeah.
So do you have any cloud use case or just on-prem?
No. Some of the while promoting, suggesting the data break, some of the customers are saying, does this run in on-premises? That's why I want to make sure this is also can be this is also possible only on the cloud or can be deployed on the on-prem.
For now, only cloud. Yeah, in future we'll be having on-prem support as well.
Yeah.
Right.
Yeah, no problem.
Yeah, we can reconnect offline and share the benchmark.
Yes. Thank you.
Sure.
Okay, with a minute to go, just one final call for any last questions. If not, we'll close out, and thank you all for your time and attention today. It's been great to have so many of you online with us. Any final words, Vihag or Ashish?
Well, what can I say? Thank you for attending. As Matt said, it's been a real pleasure guiding you through streaming analytics and how you can achieve the same on Qubole. If something has caught your eye, please feel free to contact us. We are always there to help with any questions or queries you might have, or ready to help you in any capacity as possible.
Thank you all, and goodbye.
Yeah, thanks everybody. Bye-bye.
Bye.